Hi, and welcome to this video on the scientific revolution. This video will provide an overview of the key ideas, people, and future impact and influence that the revolution had on the world as a whole. Let's get started. The scientific revolution was a period of significant advancement where new methods of scientific research were developed from around 1550 to 1700. The era saw a shift towards experimentation and rationalism, breaking away from traditional assumptions. The greatest strides forward were made in the fields of astronomy, biology, chemistry, mathematics, and physics, with the works of such scientific minds as Bacon, Copernicus, Galileo, and Newton laying the foundations for the Age of Enlightenment which followed. The publication of Copernicus's On the Revolutions of the Heavenly Spheres in 1543, the year of the author's death, represents a good starting point for the scientific revolution. His groundbreaking work in astronomy aimed to advance the heliocentric view of the universe, namely that the Earth and the planets revolved around the Sun. This was not only a challenge to the contemporary Ptolemaic view of the universe, which had been the standard for almost a millennium, but represented a direct contradiction to the teachings of the Catholic Church. As such, the book was later placed on the Papal Index, a list of publications banned by the Church. Copernicus did not live to see any backlash for his findings, and if not for the courage of a handful of successors, his work may very well have been forgotten. The opposition of the Church was not something to be taken lightly. As part of the efforts to clamp down on the spread of Protestantism and other so-called heretical practices, the Roman Inquisition began in 1542. Tens of thousands of trials were held by the Inquisition, with over 1,200 death sentences passed. Among these was Giordano Bruno, who was an advocate of Copernicus's heliocentrism. After being subjected to a 7-year trial, he was burned at the stake in February 1600. Another successor to Copernicus, Galileo, would also be tried by the Roman Inquisition for his views. Among other achievements, his development of a new type of telescope led to the discovery of 4 moons around Jupiter, known today as the Galilean moons. Galileo's laws of motion would also lay the foundations for Isaac Newton's 3 laws of motion, cornerstones of modern physics. Galileo is today considered one of the most important scientific minds in history, but his views were seen at the time as heretical by the Catholic Church. In 1633, he was forced to recant his views and spent the last years of his life under house arrest in Florence. As well as looking to the night skies, scientists also looked inward and made some important discoveries in anatomy. The English physician William Harvey, for example, used dissection to understand and describe the human circulatory system. Francis Bacon, another Englishman, advanced the notion of disproving an idea through rigorous experimentation. Only if an idea could be proven repeatedly through the replication of experiments could it then be said to be true. This is known as inductive reasoning, a probable conclusion based upon repeated observations. These ideas were outlined in the 1620 publication Novum Organum, or New Method. The idea of a new method was in reference to the ancient idea of deductive reasoning, the idea of a premise leading to a certain conclusion. A contemporary of Bacon, French philosopher and scientist René Descartes' famous statement, "I think, therefore I am," is an example of deductive reasoning at work. What thinks must exist. I think, therefore I exist. While differing in their reasoning, the aspect of doubt was central in the philosophy of both men. The other key overlap, and one of the main driving forces of the scientific revolution as a whole, was in their desire to revise and overthrow the ideas and methods which came before. Much of mathematics and scientific research today is a synthesis of the ideas first laid down by Bacon and Descartes in the 17th century. Another prominent figure whose work remains impactful to the present day was Isaac Newton. Newton was an English scientist and philosopher best known for his three laws of motion and his theories relating to gravity. The common story that Newton's eureka moment came after a wayward apple fell on his head wasn't quite what happened. He would later relate to a colleague that his gravitational theories were partly inspired by the downward path of apples falling from trees. As previously mentioned, Newton also developed the three laws of motion, which provided the basic principles of modern physics. These ideas, and others, were outlined in Newton's seminal work Principia Mathematica, which was first published in 1687. The ideas of the scientific revolution carried over to the 18th century and into the fields of political theory and philosophy in the Age of Enlightenment. The ideas of challenging conventional wisdom, building on new ideas, skepticism, and the use of reason over religious dogma were all key points of the Enlightenment and originated in the scientific revolution. Despite the significant barriers to acceptance in the scientific community, several women were able to make important contributions to the scientific revolution. In Germany, there were a significant number of female astronomers, including Maria Kunitz and Maria Curie. Kunitz spoke several languages and had a talent for simplifying complex ideas. In 1650, she published Urania Propicia, which helped to correct and simplify early works in understanding the elliptical orbits of the planets.
The formidable efforts of Émilie du Châtelet
to translate Isaac Newton's Principia helped bring the work to a much wider audience. She completed this task while heavily pregnant at the age of 42 and died shortly after giving birth. Okay, before we go, let's go over a couple of review questions. Number 1, Descartes' famous quote, "I think, therefore I am," is an example of A, inductive reasoning, B, deductive reasoning, C, heliocentrism, D, none of these. The correct answer is B, deductive reasoning. Deductive reasoning was the ancient idea of drawing conclusions from general premises. Bacon favored the idea of drawing conclusions from more specific instances, which is known as inductive reasoning. Number 2, which of the following drove the scientific revolution? A, challenges to authority. B, building upon ideas. C, skepticism. Or D, all of the above. The answer is D, all of the above. I hope this review was helpful. Thanks for watching, and happy studying.